Today in class, we did an activity where you had cards with different stick figures drawn on them, and your goal was to organize those cards into a block based on characteristics that they had in common and things that they changed on gradually. And that whole activity was to give you an idea of what the scientists went through back in the 1800s and 1900s as they were first organizing the periodic table of elements into what we have today. So these notes tonight are to give you just an introduction on the type of information we can figure out from the periodic table. So the very first periodic table was designed by a man named Dmitri Mendeleev in the 1860s. And as you can probably tell, he wasn't from America, he wasn't from Europe, he was actually from Russia. He lived in Siberia. And at the time, this is all before J.J. Thomson had discovered the electron, and at this time, the scientists all thought that atoms were just those, just a ball-like structure, the way that Dalton thought. So when they were organizing the different elements as they discovered them, he noticed that there were some patterns when they were all arranged in order of the atomic mass, from the smallest to the largest. So when they arranged them by atomic mass, he found that patterns appeared where the elements actually shared some chemical properties and some physical properties. And so a picture of what he did is on the following slide. So here is an example of what Mendeleev thought as he was putting a list together of the different elements known at the time. It was around 50 to 55 elements that they were aware of, and he put them in order of the atomic mass. So that's what all those numbers mean that are written next to the element symbols. And you can tell it's a little jumbled, and it's as organized as they could get it, but what we know today gives us a lot more information. So we can fast forward about 50 years to the 1910s, so like 1911 or 1912, around the same time as when Bohr and Rutherford were making their discoveries. A man named Henry Moseley in Great Britain had done a lot of experiments to realize that an element's atomic number matched up to how many protons were located in the nucleus. And again, remember, Rutherford is the first one that said anything about a nucleus being in an atom. And because of those characteristics that he noticed had kind of repeated in terms of placing the elements in order of atomic number, he rearranged a few of Mendeleev's ideas to create the periodic table that we use today. So this is a little bit fuzzy, but I really like this version of the periodic table that I found online because the colors show you when scientists knew about these different elements. And so this is a picture of what the periodic table looks like today, and over the next few weeks we'll get lots more information about different characteristics of elements that we can learn just by reading the blocks of the periodic table. The main function of the periodic table is that we now have something called periodic law. This tells us that physical and chemical properties, so these characteristics of each element, are a function of the atomic number. So that basically means if I look at the atomic number of an element, I can tell a lot of information about it before I even see it, because the atomic number determines these things. So the number and also the arrangement of the atom's electrons, so where they're all located around the nucleus, tells me how the element is going to act in its chemical properties. So now in the 2000s, we know that there are over 110 known elements on the table. We're still finding elements today. Most of the time now we're finding them in the lab setting where scientists are creating them. No element greater than 92, the atomic number, is found naturally on Earth. Everything above 92 is made in a lab. And we talked about that before when we did the element projects. So as we get into deeper discussions with periodic tables, we do need to have an understanding of some of the vocabulary. And today we introduce the idea of periods being known as the horizontal rows on the periodic table. So these go from left to right. And on the table that we normally use and that's in your agenda and your book, there are 7 periods total. And an interesting thing about this that we'll look at in class is that parts of periods 6 and 7 have actually been cut out and are placed at the bottom of the table so that we can smush the rest of the periodic table together and make it shorter. This is mostly for the purposes of publishing this in textbooks, so it doesn't take up what would be 3 or 4 pages in width. So we know that the periodic table is set up in terms of rows and columns, and the vertical columns are known as groups, and they're also known as families. And we'll learn a little bit about why they're also known as families in the next few weeks. There are 18 total groups on the table, and one cool thing about the groups is that they all have the same number of valence electrons. These are the electrons that are located on the very outside of the atom when they're spinning around the nucleus. The groups can also be used to help us predict how reactive the elements are. And that basically means how the elements interact with each other when they're put together in compounds. Because of the way the elements are arranged, they naturally have lots of things in common based on their location on the periodic table. So for example, all of the metals of the periodic table are located to the left of the zigzag line. So when you look at a periodic table, you'll notice on the right-hand side, there's this bold line that looks like a staircase. So most of the elements that are to the left of that line are metals. There is just one that is a nonmetal, and that's hydrogen. We'll discuss why hydrogen is on that side. Everything else that is a nonmetal is located to the right of that zigzag line. And then the elements that are touching the zigzag line are called metalloids because they have properties that are like metals, but they're also like nonmetals, kind of depending on the situation. So as we look at the periodic table, moving from left to right, atoms have increasing nonmetallic properties. So they basically are less and less like a metal as you go from the left to the right. And it gradually changes, kind of like when you were working on your cards with the alien stick figures today. They had to have characteristics that changed little by little as you went left to right. The periodic table is arranged in order of atomic number from left to right. So just like reading words across the page of a book, the atomic number goes up little by little. So tomorrow we're going to spend lots of time looking at the periodic table and getting to know it better. And you'll fill out a packet and color a little bit. And by the end of this month, you're going to be pros at being able to read the periodic table. So come in ready with your agenda, and you might want to go ahead and take a look over the elements and how they're arranged before you come into class tomorrow, so you'll be ready to go. You have a great evening, and I'll see you then.